Okey lah, boleh start. Dari siapa? Sonia dulu.
Baca soalan kan? Bacalah.
Apa?
Ya,
Okey.
baca soalan kan?
Mana-mana boleh je.
Baca soalan kan?
Boleh.
Okey, dapat.
Kejap. Saya baca ke kamu baca?
Saya baca. Sama.
Okey.
Saya share screen dulu. Nampakkah screen saya?
Nampak.
Guys,
Boleh nampak.
nampakkah?
Tampak Son.
Okey. Japan leg. Nampakkah?
Ya, nampak.
Nampak.
Okay.
Ya, nampak.
Sorry lambat.
Tak apa.
Okay. Okay, for question A, use a degree of freedom analysis to prove that if the percentage excess air are specified, the molar composition of the product gas can be determined. Okay, first, kita orang kan, kita orang tu buat dia punya complete balance equation. Dah balance kan, and then kita orang draw flow diagram, and then we assume like since this is the complete combustion, right? Complete combustion punya balance equation, we assume that it starts with 100 mole of butane. And then for the unknown, there are 1, 2, 3, 4, 5, 6. There are 6 unknown. For the first unknown, number of mole of air, number of mole of oxygen, number of mole of nitrogen, number of mole of butane, water, and carbon dioxide. And then we have 4 species. We have carbon, hydrogen, oxygen, and nitrogen. And then we can, for the percentage of excess air, it can be related to the percentage of conversion. So for the degree of freedom analysis, we can use the formula of number of unknown minus the number of species and minus the number of relation. So for the number of unknown, there's 6. There are 4 species, so number of species there are 4. And for number of relation, there's 2. So equals to 0. That means that it has, what should I say? It has enough information to determine the composition of product gas. Okay, that's all for me.
Thank you.
Got question kah?
The percentage of
Okay.
the excess air is 100%.
Percentage of excess air.
Yeah.
It depends, right?
Yang tu belum dibagi, not given yet in question A.
Not given kan?
Yeah, not given, just itu just apa tu?
Analysis je ni.
Analysis, yeah.
Assumption kiranya.
Betul, assumption.
Yeah.
Okay. Faham.
Okay, thank you.
Tu aku belum buat lagi ni untuk A ni. B1 ni.
Apa tadi?
B1 aku belum buat lagi.
Oh, okay.
Hello.
Ha,
Boleh nampak ke skrin saya?
nampak.
Boleh. Nampak.
After we find the combustion reaction and from the block diagram, we can see that from the combustion reaction, we can see that 1 moles of butane react with 6.5 mole of oxygen to get complete combustion. So from the relation, we can find mole of oxygen used for the combustion by given the basis 100 mole of butane, right? So which means that 100 mole of butane equal to 1 molecule of butane react with 6.5 mole of oxygen. So we can multiply 100 mole of butane with 6.5 mole of oxygen, and then we can get 650 mole of oxygen used for the combustion. So from the value of oxygen obtained, we can get the amount of air supply into the reactor. Give in the air there are 21% of oxygen, right? So 650 of 650 mole of oxygen times by 1 mole of air per 0.21 mole of oxygen in the air, and then we get 3095 mole of air fed into the reactor.
Okay, understood. So, ada lagi ke?
Hello.
Aku tengah buat ni B1 ni. Terlupa tadi.
Ya kah?
Ke
Ya,
So
ingat.
macam mana?
ke Sam nak
Ha?
saya dulu, lepas tu kamu kemudian.
Ya, boleh.
Okay lah, saya dulu lah. Yang Rosnah punya tu boleh lah, unshare punya lah.
Wait, macam mana mau unshare ni? Astaga. Sini jumpa.
Sambung dari Sam lah sudah. Yang kamu dengan Son dengan Rosnah tak perlulah. Saya sudah save. So kita
Okay.
So kita boleh jam dekat Samuel terus lah. So Sam boleh terus lah.
Sekejap ha.
Okay.
Semula nampak kah?
Boleh?
Okay. Saya start dulu ah. For question number 1, since conversion of butane is 100%, so the most of the butane and the oxygen will both be zero. Yeah. And now calculate the mole for each atomic atom, such as nitrogen, carbon dioxide, and H2O. For the nitrogen, you need to calculate the 0.79 mole of nitrogen times by the 3095 mole per air, and you get 2445 mole of nitrogen. For mole of carbon dioxide, you calculate 100 mole of butane times by 4 mole of carbon dioxide over 1 mole of butane, then you get 400 mole of carbon dioxide. For mole of water, calculate 100 mole of butane times 5 mole of water over 1 mole of butane, then you get 500 mole of H2O. Faham kah?
Faham?
Okay. After that, you can calculate the percentage of each gases in the product. Means you need to calculate all the atomic product lah. For the percentage of nitrogen gas, you calculate the mole you calculate just now over the N total. N total to all the 3 atomic lah. You calculate. Then you get 3,345 mole the total of for each mole. Times by 100, you get 73.1%. For the percentage of mole of carbon dioxide, 400 mole over 3,345 mole times 100, you get 12%. And lastly, the percentage of mole of water is 500 mole times 3,345 mole times 100, you get 14.9%. Okay, itu saja.
Okay. Nampak tak yang screen saya ni?
Nampak?
Okay.
Eh? Ya.
Okay, kejap ah. Okay, for my next question is about this 20% of XSA and 90% of conversion of butane. What the meaning of 90% of conversion of butane? Sorry. It means, okay, if you see from the flow diagram, this is the 100 mole of C4H10, and this is the percentage of the XSA. And this is the composition of the inner product before product. So this one, the composition before this is the oxygen and nitrogen. Okay, the one that we need to find is the percentage of the product, exit product. That is N2, H2O, CO2, N2, and O2. Okay. For this question, 90% conversion of butane. It means 90% of this H2, 90% of conversion of C for H10 butane is converted inside this reactor. So only left 10% mole of C4H10 out of the product. So we already found the C4H10. So that left is this 5 composition to this 4. Sorry, suppose it's 4. Yes. It's okay, next we need to find the mole of this composition. So first we need to find the composition of the O2. So how do we find it? Okay, before this, we based on the equation from Sonia given is 13 over 2 of O2 is completely balanced from the equation. So 13 over 2 times with 90 mole of C4H10 that have been converted to get our exit product. Is about 1 mole of C4H10. So we cancel out the unit, so it left with mole of O2. So we can get our product product mole of O2. That is 5 5 at 5 mole. Paham ke? Ada yang tak faham? Ada yang faham ke? Kita faham.
Setakat ni faham.
Okay lah. Okay, next. Next, we need to find the excess air for the outside the product is given from the question is 20% of excess air. Sorry. So we need to find the excess air for 20%. So 20%. Yep. 20% of excess air is equal to number of mole of air equal 1.2 1.2. Why is 1.2? Because it's excess air, right? So excess is mean tambahan. So 1 plus 0.2 from this 20%, so you get 1.2. Then you multiply with the Then you can multiply with the number of mole of oxygen from this previous answer from who? From Samuel. So the excess number is 3095. I mean not Samuel, I mean from Rosnah one. Rosnah part. Then you can get 3714 mole of air. Okay. Now you have air, so we can get our for number of mole of every composition of the product. So for CO2, H2O, O2, N2. For butane, it is already be given 10 mole because of the conversion of 90%. So 100 minus with 90%, you can get 10 mole. Okay, for exit product. And CO2 equal to 90%, 90 mole of excess air you multiply with 4 mole of CO2 over with 1 mole of the excess wrong. Sekejap, salah. Not excess air. Butane, sorry. C4H10. 1 mole of C4 H10. So we can cancel out the unit. You cancel out this unit, then you multiply it, and you can get the answer for mole of CO2. So the answer is 360 mole. For next part is we need for next we will find for H2O. H2O still the same using this method. So 90 mole you multiply with 5 mole. The 5 mole of H2O we can get is from the balance equation from the Sonia given. From part Sonia you can see from the balance equation, so you can get this 5 mole from the equation. 1 over mole C4H10. So you can cancel out and then multiply it, you can get 450 mole of H2O. Next is for we need to find the number of mole of O2. So the number of mole of O2 is different than the others. As you can see, the excess air from the excess air given. From the 20% excess air, you already find. You can find the number of mole of O2. Okay, but I will give you the and O2 from 21% over 1 mole of air times with 3174. This 3174 is from the 20% of excess air, the N air, the the one that I shown you before this. Where is it? This one. 3714. Then after that you can get the answer is 780 mole of O2. This is for the 20% of excess air, but for 100% conversion, I mean 90%. For 90% conversion parts, the number of mole of O2 from 90% conversion of butane, you can get 90 mole of C4H10 you multiply with, from the balance equation, 6.5 is the same is the same as 13/2 mole of O2 over with 1 mole of C4H10. So we can cancel out the unit and you can get the answer the answer is 585 mole of O2. Okay. Then we need to find this answer for the number of mole of O2 of the product. So the number of mole of two product is 780 mole minus with 585 mole of O2 equal to 195 mole of O2. This is for the exit product. So be careful. Okay, next will be we need to find the number of mole of N2. Number of mole N2 is from the percentage given is 0.79. 0.79 over with 1 mole of air, excess air, times with the amount of excess air total given from the beginning is 3174 mole. So you can multiply it, you can get 2934 mole of N2. So that's how we get it. So paham ke tak? Faham ke korang?
Oh, macam tu.
Hmm?
Macam mana kau dapat 85 tu?
Saya dapat dari 90%. Ni 90%
Oh,
90% conversion saya tolak lah sebab ini dia gabungan kan. Kalau kamu tengok yang dari Sonia punya ni, dia punya flow diagram, ini combine. Kamu akan dapat satu produk. Supaya itu kamu tolak. Saya tolakkan dapatkan dia. So, saya tolak daripada 90% conversion tu. Yang keluar tu. Ini 100%. Yang ini 90%.
Okay.
Okay. Okay, next we need to find the percentage. So the percentage is the same like the formula from Samuel. Percentage. Okay, I take example like percentage of O2 equal to number of moles of O2 equal to total number of mole composition. So dia semua produk yang itu, dia punya produk semua mole tu kamu tambah. So you can get the answer for percentage, and then don't forget to multiply with 100% to get the percentage. So I take the one example lah. Kejap. Mana O2? 1950. 1995. 195 over with the total number is 195 plus 2934 plus 450 plus with
Magician has come up with another trick.
360 plus 10.
Tough. Oh, he's done well to skip around the challenges.
So you can get the answer. Then you can get the answer for this total. 195 plus over 195 plus 2934 plus 450 plus 360 plus 10. So you can get the answer is 4.9. Oh, tak terang. Kejap. 4.9% for oxygen. Then you can find for the others. Percentage of the others. For CO2, still the same formula. Using this formula, mole of CO2 over the total number of the composition. Still the same. For CO2, you can find for the butane. You can find for the H2O. And lastly for N2, for composition for N2. So faham? So you guys understand lah? So yang lain faham ke? Ada yang tak faham? Ada yang mau tanya soalan? Ada yang tak faham ke?
Faham.
Faham.
Okay.
Saya pun faham.
Okay. So itu sajalah saya punya part. So thank you lah. So antara kamu tiga ada apa-apa mau tanya, ada soalan?
Tak ada soalan.
So far tak ada.
Sam?
And untuk parts tu kan,
Aha. Apa?
balance equation saya kan serta tinggal 4 depan
Tak apa.
carbon dioxide.
Tak apa.
Okay.
Okay. So, I think itu sajalah. So, Sam ada soalan, Sam?
Tak ada soalan.
Okay, I think everything. Kejap. I think that's all lah for today lah. So, everything is complete. So, everyone understand. So, you guys may leave.
Okay, I mean.
Thank you guys.
Thank
Okay.
you.
Okay.
Thank you very
Bye-bye.
Okay.
Bye.
Bye.
Bye.